Yeah, okay. So, welcome all. This is Python Bootcamp, where we'll be teaching you basics of Python, so that it can also help in your CT courses which you might take. And also, it's just a beginner for guys who don't know much of programming. And we'll try to cover much of the essentials, and also we'll try to add an ML flavor, as in where the Python is most used in ML. So we have guys who are actually mentors and instructors for the from the same course, that is MLDL. They'll be teaching you basics of Python and how is it useful in ML. So let's just begin. One moment. I'll share my screen now. Visible?
Yeah.
Yes.
Okay, okay, fine. So in case you guys have any doubts, we have people to answer your doubts. Do put them in the chat box, and occasionally you can even switch on the mic to tell your doubts. We are recording this session, so hopefully if any of your friends don't see this session, they can watch the recording later on. Okay, fine. So let's just see. Okay, so one of the basic questions which I want to answer just before starting, that why Python? So some stats, like it was created in 1991. It is an object oriented language and a high level programming language. What do I mean by high level programming? It means that it uses compiler or the interpreter to run the programs, right? So what advantage does an interpreter have over other, like a compiler? I'll tell you later, like how I'll show you a small thing, how does it give you an advantage. But in Python, you do not need to, specify the types of the data you are using. You don't need to specify that this particular thing is a string or this is a number or anything of that kind. So that is where an interpreter helps. We'll see some examples later, right? So Python is converted, like when I run Python file, like I have this, I'll show you the installation later. This is ideally where I'm using to write the code and run. This can be installed in your systems. I'll tell you just in a moment. When I write a code, maybe like a code, anything do I write? Like when I run this converts it into a byte code. I can save this and maybe just write an input and get an output. The code converts it, the Python virtual machine converts it into byte code, and then the interpreter, which is Python virtual machine, this will run, right? So this is different from compilers like C++. We'll see how this is beneficial in some time. Now, some reasons on why Python is better. Like first of all, you will see throughout the session that the amount of code which you write in Python, that reduces drastically. Maybe even, like if I can compare, even 70 to 80 lines of C++ can be converted to 10, 20 lines of Python, right? We have wonderful libraries in Python. I'll show you, like the ML guys will show you NumPy and other important libraries which are helpful in Python. Apart from that, there are some other libraries like Django and Pygame, which give a versatility to Python, how various kind of activities can be done in Python. Then let's just begin with basics of Python. Okay, so first of all, I'll show you the installation. It's like really simple. I'll not install it, but you can go here, python.org, and you can go to downloads and just download Python over here. uh, and make sure, just while installing, I think I've modified, maybe. Huh. No, I guess just make sure that this is coming as modified. Just make sure while installing that you click on this tick box of including Python in your path. That will help you to run Python using CMD. Like here, you can just type on Python and you can write some code and like install libraries apart from that. Okay. So we'll just continue with Python over here. First of all, let me just tell you how do we take up input and output. Simple things. In If any one of you knows C++, I guess Some of you might know C++. If you can, if you know, just put down, just write that in chat box. Yeah, fine. So in C++, yeah, correct. I see Cin and yeah, that works, no problem. So in C++, usually what you need to write is like, I'll show you if I can. Yeah, just ignore this thing. What in C++ do you write is like in 10 comma k, you first of all tell the compiler that we are desiring to take int variables. Then we write string, just right. We are writing in 10 comma k, we are writing cn and ck. This is for input. Here we are specifying this is an integer, this is a string. If I pass on different values, this might give an error. But in Python, you don't have anything of that kind, which is where the interpreter is really helpful, right? It is the duty of interpreter to check the data and assign it a decent type. Like if I want a equal to input, right? So I can give any input in this. This doesn't, it is not a problem. Like if you write a string, if you write a number, if you write, binary code, it is not a big issue in Python. You can write one, two numbers. It will, like, this shows that this runs, no problem with that. You can even add up strings, not a problem. But like if you want to convert the inputs, you can write a equal to int of input. Right. This you will be able to, like, distinguish, have a clear cut idea that what a variable you are taking as an input. I can always check the type of an input using type. I'll just print it. Mhm. There are two inputs. Yes. As you can see here, this is taking it. This we have explicitly converted to int, right? By this, the general input is always a string type. You explicitly convert the input to string over here, sorry, int over here. With this, the type of a changes to int. I don't think this can be done in C++. Like if you want to change the type explicitly, yeah, I guess this can be done, right? But here, the general input which you are taking, it is of in string type. Like I'll show the int type of a. I'll just randomly write anything. So this is general string type input. It is not a problem that you define a as a variable or not. It's like if you define it as int or not, it is not a problem over here. Right? This was input. Next thing I'd like to tell you is how do you take multiple inputs? In C++ and I think this is also easy in C++, but compared to it, how do you do it in Python? Whatever variables you want to take, maybe A, B, and C, A, B, C equal to map, okay, comma input or split. Now, what is the split function? What the split function does is, like, the input you write, it will split down the input by spaces. I'll show you how this runs, and then the inputs will be splitted, and then they will be like added onto A, B, and C. I print A, comma B, comma C so that you can see that. Right. So maybe let's write bits, Lani, Goa. Right. So these are three words that will be splitted by the space thing. By default, the delimiter which we use here is space. Right. Just enter. Just one moment. Oh, I mapped it into int. I can't map strings to integers. That is wrong. I'll just run it again. Right. So we get bits, Pilani, and Goa as A, B, and C. This is how we take multiple inputs in Python, right? And of course, the print function is really simple. I guess in C++ you use cout, right? So the print function here is really simple. You can add on things which you want to add, and this will print it accordingly. Okay. So I guess input output is clear. Does anyone have any doubt at this moment? Like you want to try something, I can maybe even show you live.
You showed that A, B, C right now. So if we write just A, then will it print just bits out of that?
Yes, it will print just A out of that. Like I'll show you once again. A comma B comma C equal to map of, right? Int, I don't know why.
Could you explain what you exactly mean by map?
Yeah, I'll just tell you. Okay. So as you can see, this is bits, right? You are just getting A over here. Fine. Is it fine? The guy who asked the doubt.
Yes, yes.
So what does map do? As you can see, you are typing multiple inputs over here. When we were taking one input, it was fine that we were not using a map. Maybe you just write this. We don't require a map because we are taking just a single input. This would work. But when you are taking multiple inputs, you have to give this command which maps the input to the variables like this. I'll just come to this in a moment. So what this map does is you will give maybe three inputs, and then this map function will map the first to the A1, second to the B, and third to the C thing. Right? Is it clear?
Yeah.
Okay.
And
And
like, what is the
just let me
point of?
complete 1 second.
Yeah.
This int thing, this will convert all the inputs to an integer thing. That's why we were getting an error while we wrote string and we converted into int, which I guess it's not like it does not define. We can convert, we can use the ASCII value, but
If
we
there's
have
no
to.
number, then it'll show an error
Yeah,
in
correct.
the input.
Compared to it, if we write str, if we write str over here, you can actually give out numbers, but it will interpret numbers as strings. Like if I write, right, so as you can see, we don't get any error here. What does this mean? That the a thing, the a variable, it does not actually hold a number. It holds the string of 1 2 3. I can show you here. Right. It will. I'll also just print the type over here. You can remember this type command. This will actually help you to know the type of any variable which you encounter. As you can see, the class like type, you can say the type of A is actually str. So it's not a number, it's a string, because we mentioned that the input should be of string type. I think it's clear, right?
Yeah. And what is
Just a
about
small doubt.
like
Like the integers, like the int covers integers. So what all does string cover?
String can cover actually anything, like whatever input kind you can imagine, the string will be able to cover it. Like string is just like your buffer region. You can actually add any input of that kind, and you can convert it to your preference as and when you want. Like you take an input, you map it to some strings, and then you can cover it.
Okay,
Maybe
then.
if we'll get examples in the future class, I'll tell you what all types we can add. But string is sort of a buffer. Anything you give an input, it will convert the input into a string and just add that thing into a variable. I hope it's clear. Like we'll see more of these kind of examples in the future, in the coming part, right?
Yeah, okay, clear.
Okay. Okay. So this is done. I guess the basic input output is clear. So maybe just I can show you. No, let's not do. We'll do now some basic programming things, like the basic programming thing, functions and ideas which you must know. I hope you know about for loop. Like if you can just write in the chat if you know for loop or not. Yeah, so I'll just I guess okay. I'll cover it. I'll cover it. So imagine like what we usually do in programming is that we might need to do the same thing again and again. Maybe just write down 100 numbers from 1 to 100. So like what can we do? Print 1, print 2, print 3. It does not help to write 100 numbers, right? So what we use this for loop, we use for loop for this. This for loop is very generic. Like you use for loop in almost all kind of programming languages you can imagine. You use that in Java, C++, JavaScript, any language you can maybe think of. So this is the for. Like if you see, Python actually recognizes the word for it. That's why it is coming in yellow color. If I type some gibberish, it does not recognize. But for loop is a keyword. It identifies for loop. Okay. What we do here is for I in range. Okay. So please remember the syntax. This will really, you know, like this will be a bread and butter after you use Python for maybe 5 to 6 days. This will really be very easy. For I in range, here you give the starting index for a number. Like from when do you want your for loop to begin? I can write this from 5. I can write this from 7. The first value of I, the first value of I will be this number. Okay, 5. So when I write this, what does this mean? This loop will start from 5 and end at 7. Okay, so I just print I. Hope this is clear. This value, the I value, this starts at 5 and ends at 7. Is this clear? Can you write that in the chat? Hello. Okay. So I'll just print this. Okay. So what do we see here? It does not actually end at 7. What does this mean? This 5. I'll just change this and I'll let you yourself just figure out what does this mean. Okay. I actually okay. So this ends at 233. Can any one of you conclude that what does this value actually mean? You can even open the mic. This I told you was the beginning one. What does this actually mean? Yeah, correct, Goba, Shreyas. Okay. Sorry for not. Yeah, very good. I hope this is clear, right? Okay. So one more thing. Usually we just use two values over here, right? It does not help to, skip values, but if you are aware of C++, you can do that as well. Like you write I plus plus, I guess, in C++, for int I equal to 0, I less than 10, and I plus plus. You write I plus plus. What does this mean? Just increment the value of I by 1. Okay. So we can similarly write for I in range, maybe by default, this value is 0. The default value. If you write 5 over here, this will be assumed as the second value which you type. So if I just print this, this will give me 0, 1, 2, 3, 4. I'll just run this. I hope you're able to see this. 0, 1, 2, 3, 4. Okay. So this was it. What I was telling you was for I in range 0, comma, I just explicitly write 0 over here. 0, comma 10, comma 2. Can any one of you tell what would be the output over here? Just type it or say it, whatever you want. Yeah, correct. Correct, Akshay. Nice. So this 2 will help you to skip the values. Okay, fine. Yeah, apart from that, you can even maybe use -1. This will actually, like, I'll just write 10 over here, 0 over here, and -1. So output over here, like, what would be the output? Not, yeah, correct. So 10 to 1. Remember that Python will always skip this value. It will take the value just before or after this, depending on the -1 or this. I hope the for loop part is clear to the ones who are seeing this for the first time. Can anyone write that in the chat, please? Okay. So just a brief thing about if else. I hope like the ones who don't know this will be able to just make out what I'm saying. I know it's a really easy part, but why is it 1? Okay, so as I said, Mohammad Aman, it is actually the fact that Python will always skip the second index and it will use the value just before it. Like I'll show you for I in range 0, comma, okay, and print I. It will go from 0 to 9. it will skip this. What would for what would for I in range 10 comma 0? Yeah, it will, I think, give an infinite loop, of course, because you will go on incrementing the value. Like from 10, it will become 11, 12, 13. I'll just run this to show you. Did I print it? Yeah, I guess Gavish will be able to handle that. Okay. So, any other doubts? Okay. So, I'll just cover the if else part over here. What do I mean by if else? I guess you know if else. Like, if something is true, then do this act. If it is not true, then do something else. Like, if I'll just use some input equal to input. If a equal to bits, right? And I am happy. Else print I am still happy. Okay. So we'll just run this. We'll give some input. Okay. So it's very clear, I guess. Okay. I hope Anirudh's doubt is cleared. Yeah, great. So I hope you are seeing this here. If I give an input of bits, it will compare this with the string bits, and it will give I am happy. I'll run this again to show some any other input, maybe anything. Let's just try. I'm still happy. Okay. So this is not actually equal to bits. So we'll just print I'm still happy. I hope this is clear, right? Okay, great. So this is if else. I'll show you something about something called nested if else. What if we want to give more than two conditions? If a equal to bits, then print which I love, maybe Goa campus. Okay, so the ones who know C++, this might be equivalent to else if. I guess this works here as well. What we write in Python is elif, which is same as else if. If a equal to maybe whatever. I'll just use the campus name, I guess. Lani. And it is really hot here. Let's and wow. Right. So we'll take an input. Okay, I'll just cover this part up. I'll just cover this part after this moment. I'll just explain you what are brackets over here. Okay, I'll just give any input. Maybe Goa. Love Goa campus. Right. If we write Pilani, what do we get? It is really hot here. And if we write some gibberish, maybe wow. Okay. So this is if, else if, and else part. I'll tell you about the brackets. In Python, we do not need brackets. It is something how now if we don't need brackets, how do we define the scope and that part? So let's say right maybe if x equal to y. So if you note it, I'll just zoom in. I'll just make this bigger. If you note, I was writing over here and then the cursor comes over here, right? So what does this mean? That this is some scope. Now when I click enter, it goes over here, not here. Okay, so there's the tab of difference. I write something, something, and something. Okay, now I click else. So this will be one scope. Now if I write if, another if in the else, okay, so this will be another scope. We do not need brackets over here because the scope and that part is actually defined by the spaces. If you see this, there will be two spaces over here. and here there will be a single space. So that will actually help you to tell what scope is going on. Yeah, four spaces or the tab, right? I hope this is clear. If you can just comment out or maybe speak on the mic. Yeah. So the ones who are doing C++, they might find it a bit odd, but with time, this will actually help you to keep your code more indented and much more readable format. Okay. So I have covered for loop. I have covered if else. Uh, do you want me to cover while loop? Somebody can just say on the mic.
Yep.
Okay, I'll just cover that. No problem. So in for loop, what you would have realized is that we actually know what's happening. Like I write for I in range 5 comma 10. So before, so while writing 5 comma 10, you know what will be the output, like how many times it will run or what will the values of I be, 5, 6, 7, 8 and 9. What if there is some random input from the user? Okay, equal to int of input. What if you don't know what is your stopping condition? You know that you have to stop in this case. Just a moment. In this condition, you know when your I will stop. The moment I becomes 9, it won't run after that. What if you don't know that when it will be stopped? Right? Fine. I was just reading the chats. What if you don't know when this will stop? Okay. And like maybe while A, A is greater than 10. Okay. The for loop and the while loop are the same things. They help you to iterate. But in while loop, if you are not sure that when this condition will be achieved, maybe I'm doing some random maths with this. Maybe a plus equal to 1. This is same as C++, a plus equal to 1, and the way you update variables, a plus equal to 1. And then maybe I write a minus equal to 2, a is equal to 5 into a. Right? Whatever do I write over here? You don't know when this will be true. Okay. Equal to int of input. No, it won't be an indefinite loop in all cases. There can be indefinite loop. If I don't write anything over here, right, and if I give an input of 10, maybe 20, so it will be always greater than 10. 20 is always greater than 10. So this will go on and on and on. This will actually be an indefinite loop. If I can update this variable by let's say minus equal to 1, it will definitely terminate at some point. Right? Maybe 13. Oh, and print anything. I need to give an input. So when I give 20, this will definitely terminate at some point. The moment it is 10, it was not greater than 10 and this will not continue, right? But when I write maybe something less, something maybe less than this, this does not go in the for loop for that place, for that matter. Okay, let's just try this for that moment. It's not going into that loop. Okay, so as you can see, this is going to infinite. Why? Because A will always be greater than 10 and it will go on and on and on. So this is one thing which you will need to see carefully in while loop. Like you need to make sure that the termination is there properly, right? So as I mentioned earlier, what if you don't know when this condition will be true? You are doing some random maths in A, maybe A minus equal to 1, A plus equal to 5, like reducing A by 1, adding 5, and maybe A is equal to 5 into A. You're not sure that when this loop will terminate. Right? It's not really simple that you are at A equal to 5, you need to reach at 10, A equal to 15, and then you increment a by 1. Acha, a minus equal to 1 means reducing a by 1. Like if a is 5, it will be 4. If it's 4, then it will, correct, as Gavish mentioned. Right. If you're not sure what will actually happen in this loop, you use while loop. You don't know when this will terminate, but you just need to make sure it will terminate at some point so that it does not go into infinite loop. If there is any value, I can show you. A 7 7 6 6 11. Okay, so this will actually increase by a lot. Let's just try with something. Acha, I'm not printing anything now. So I guess it's going really bad. So I hope the idea is clear, right? If anyone can confirm. Okay, so this was just basic programming which I told you guys. For loop, while loop, if else. Okay, so let's now come to one of the best parts of Python, like the way it handles strings. Okay, so the ones who have done that in C++, you will find it really, really fun as to how Python handles strings. Let's just say any string. Hey there, it's me. This is a string, I'll just print it. There it's me. Okay. We have the string over here. How do we, how do we find a character of that string? It type s of 0. I'll just tell you about how is this indexing done. I'll just tell you that. So if any one of you can tell me what's the output we'll get.
H.
Yeah, correct. Great. Alright, just close that part. Okay. So the ones who do not know, the indexing in Python and in any language, it's the zero-based indexing. The first character is actually indexed by the 0th one. The nth character is indexed by the n minus 1th character. So if you want to get y, it's actually the third character, 1, 2, and 3. You get it s of 2. Okay. It's a zero-based indexing which we follow. This is, I guess, common to all the programming languages. I hope you are able to understand that why s of 2 is actually giving y. Is it fine, guys? What if we print S940? I'm not able to understand that. Okay, should I print S of 4? Akshay. Okay. What do you expect? What will you get over here? No, I guess you'll get T over here. Yes, you'll get T. Why? Because this is the first character, this is the second character, E is the second, third, fourth, and fifth. He is actually the fifth character. So get that character, you'll use 4. Okay. I hope this is fine.
So for 9, it will print comma, means comma is also taken as character then.
Yeah. Comma is also a character. Is it clear?
Yes.
Yeah, Manan. Yeah, it's a blank. It won't be able to. You won't be able to see anything, so no point printing it. Okay. So I hope you get this. What next? Okay. So I'll just show you something really nice. What if you want to get? It's a very big string. You are not concerned about what's the length. You don't know what's the length. Even though you can find the length, but what if you want to get some random guy tells you, tell me the second last character. So what you will maybe technically do in Python C++ is s dot size -2 something. What you can actually do in Python is use negative indexing. You can type minus of 2. What do you guys expect we'll get over here?
S.
Yeah, correct, Anirudh. Very nice. So in negative indexing, actually, this might take a bit of time to wrap around your head. Just one moment. I'll just come in a minute. Yeah, so I'm back. What I was saying was that in Python, the forward indexing is actually the zero-based indexing. When you type s of -2, it will actually give you d. By writing -1, you'll get s. By writing -3, you'll actually get this character, this one. If you type s of minus, sorry, let's type this. If you type s of -4, you'll actually get g. So while writing negative indexing, it will actually follow normal indexing or the ith character or at that time. Okay. So when I write s of -3, right, what do you guys expect we'll get?
S.
Yeah, correct. Very nice. We'll get s over here. Okay. So this is one thing which was not, I guess, there in C++. This helps us to be really, this makes Python really easy in some ways. Okay. Next, what we want to cover is string slicing. Okay. So what if we want to just slice some part out of it? We want to make it the negative indexing. I'm not sure. I guess it's there. It gave some error to me. Like, okay, we'll just see if it's there or not later. Okay. So what if we just want the part A over here? It's 3 characters. What we can, I just come in a minute. I'll just come in a minute. Hello, am I audible?
Yes.
Yeah.
Yes.
Huh. So what if we just want 3 characters out of here? What we will do is print s of, maybe just store it some in another string, s of 0 to 3, print x. We get hey over here. Now again, the way I told you in for loop, it will not actually take the third indexed value. It will not actually take the space. From 3, it will understand I need to go till the index which is 1 less than this. Okay. S of 0, 1 and 2. That is all the number of indexes it will take. I hope this is clear. Like if I type 4 over here, then I'll get a space. Like it's not visible, but let's just say. So we are getting hey t over here, which means by writing 4, it will go till the index 3, right? Index 0, index 1, index 2, and index 3. Do you get this? Okay, great. Very nice. Really nice. Okay. So this, I guess you have understood. Similarly, the way we saw in for loop, you can always skip indexes. This is not really helpful. I'm just showing for the sake of it. You can maybe if you're not able to understand this, you can completely ignore this. Maybe just okay. If I do not specify anything, it will assume it to be the whole length. Okay. I'll just show here. Uh, by default, it skips by 1. By skipping by 1 means it iterates by 1. Now it will take up alternative characters starting from the 0th index. Okay. What do we see here? H, then skip I, skip D, then Y, then skip T, then H, and so on. Right? You get this, right?
So your space is also counted, right?
Yeah. Space is a character. It is a valid character. If I write 3 spaces, it will actually count it as 3 characters. So the thing I told you that this 2 thing, this is actually a skipping thing which we saw in the for loop. Like when I saw you for when I told you about for I in range 0, 5, sorry 0, 5, 2. So this will go by 0, 2, and then 4. Right. So it's the same analogy over here. When we write, hey there, it is me. Right. You get this, right? Okay, I'll just continue. And lastly, one important function. What if we want to know the length? Like it's really, really long. What if we want to know the length? In len of s. Okay. S, I guess in C++ you use s dot size or something, but here we use len. Okay. So this was of 18 length. What you can also see is that I guess maybe in string, no, I guess there's no limit. You can always add stuff, and apart from that, last thing, we'll see how to add strings. Right. Let's say name, let's say my name is Tanmaiy. My surname is this name. Yes, Akshay. It does include that. Okay. What if I write S plus S name? What do you guys expect? You can even type or maybe just say what will happen.
Tanmaiy, Sethia. Like,
Do we? Yeah, correct. Yeah, correct. We'll get that.
Simply just combine.
You repeat, I didn't hear you.
I think if we put a comma, there would be a space, but
Getting the space, we can type this. Like we'll just add one space character over here. Is it fine now? Okay, great. So how do we add strings? We can always write some gibberish and we can add that. In the order, we'll add obviously in the order it gives. We'll just add over here and we'll print what we'll get in. And space and something. Okay. Does the comma also do the same job? Like what job are you referring to? No, I guess not. I guess not. Yes, comma. No, it will actually the comma will be used by the printing. It will actually Tanmaiy and Sethia. It will not actually add. See, there's a difference. When I write x equal to s plus s name, x will actually get the print part over here. In x we'll get Tanmaiy Sethia. Right. By printing, you can say that comma might do the same job. Like by comma, you get a definite space. Okay. But while writing, like if you want to save MS ATI in one string, you can definitely not use comma. By printing, it actually does the same job. Okay, great. Great. So I told you functions for string, maybe anything else. Yeah.
I actually had a small doubt. Hello?
Speak up, speak up.
While printing out specific characters from a string, you did square bracket 0:3, for example, right?
Mhm.
So the number of colons signify the number of characters it skips. Like if you put two colons, it'll skip two character, three, it'll skip three, something like that.
See, there are three such things. Like the skipping part, that's why I didn't like wanted to, explain it completely. See, there are three parts. One, two, and the third one. Okay. So what happens is that the third value over here which you add, okay, that is the one which we'll be using for skipping. If you don't add, it's perfectly fine. It will just iterate. Like
Okay.
maybe
So in
add by
this
one.
case, it'll be 0, 1, 2. And if you add like 3, it'll be 0 and 2. Okay.
Okay, you
Okay.
get it, right? Okay.
Okay.
See, I'll tell you the order. When you type S of 5, okay, so S of 0, this will actually give you the first index, or maybe, this will actually give you just one index. When you write this, what does this mean? By default, its value is 0, right? By default. So it will actually print 0, 1, 2, 3, 4. Tanma. It will print TANMA. So colon is just for, I guess Gavish will be able to see that. So 0 to 5. Okay. It's the kind of default value which the Python always saves. Like it will understand what we are trying to say. If we write s of 0 to 5, it is same as s of 5. Right. So if you do not write anything in the third blank, it will understand it as 1 or 0. Right. So it would not be a problem. It's the general programming logic we use. That one iteration thing. If you want to change it, you are most welcome to change it. Okay.
Okay, thank
So
you.
one more thing, just very important, not really like important, but yeah. If you try to do this, what do you guys expect? Let's just see what happens. So this is an error. We'll see something which does not give this error. This means that the strings are immutable. You can always add stuff. Maybe sorry, s plus equal to refresh. This works. You can always add stuff, but you cannot change stuff. You cannot change T to S. You cannot change its characters. Okay. You can remove characters. I guess S dot pop is something that you use. Okay. So I guess you cannot even use pop. Okay. You cannot change the string. You can always add other things. Right. I hope this is clear. You cannot like somebody wrote Sunman, but it would not work like that. I hope this is clear, right? Okay. So I guess I have covered major part of strings. Um,
So that plus equal to means we are adding something in that stuff.
yeah. We'll be adding, if we write
We
plus
are
equal to, that means we are adding stuff to the string. Correct?
so the after the equal to whatever we write is added in S.
Yes, correct. So
Yeah,
I guess
okay.
that is clear, right? It's clear, right? Okay. So just one thing before I finish my part, like I had planned a lot of things, but I'll tell you the important ones. We'll look at what is something called as list. Okay. So you guys might know about array or vector for that matter from C++. I guess in Java also you use array list. I guess you use array list. You know that, right? Okay, great. So what we use usually in Python is something called as list. How do we define a list? We just say ans equal. I'll just this thing. You can see that list is a keyword. It will come in purple. You can see that, right? Okay. Ns equal to this. What does this mean? I guess I'll just bring the type of this. That will be really clear. Okay. You can see that this is something called as a list. It is it we'll see why this is not actually an array. Array has a defined size. I nowhere mention what is the size of ANS, right? For an array, you have a particular size. In vector, actually, you do not have any size, but in ANS, you do not have any size over here. Okay, so you have seen that ANS is a list. Now, what do we do with this thing? Maybe we'll just try to add stuff into it. ANS.append 23. I didn't print anything. So as you can see, 23 has been added to this list. It is sort of equivalent to a vector in C++. It is different from an array you have seen by. It does not have a predefined size. Now, what actually makes it even more versatile than a vector is that might be expecting that we can just add only numbers over here. But no, we can actually add anything over here. Let's just try this. Right. So you have added a number 23. You have added a string over here. You can actually add anything over here. Right. That is different from vector. What you do in vectors, you actually define a type for the vector. Is it int type? Is it char type? Is it string type? And what all? You can actually add anything. For adding elements, we use dot append operation. So I'll just show up again ans equal to this, ans dot append, anything which you want to write. So different data types cannot be used in array. No, they cannot be used. Okay. So we can append anything over here. Like there is something called as default dictionary or dictionary. We can even append anything. I hope you get the idea, right? Okay, great. So I've told you about list. Okay, some important functions for list. How do you index a list? Same way how you index a string. So ans equal to 1, 2, 3, 4, 5, 6. Print ans of 1. What do you expect here to come? Very nice. Very nice. Great. So, and similarly, we type ans of -1. What do you expect now? Great. And again, similarly, what do you expect now? So that's 1, 2, 3. Yeah, I guess that would be fine. It's not a string type, it is a list type. So it will come with this braces and all, but no worries about that. Similarly, you can always extend -1 to it. I guess we covered this, right? Did we? I'll just show again if we. This is 6. The same way we index the string, we index an array. Okay. We can always add things of various kinds to it. Okay. What we can also do is uh, maybe add arrays together. ns equal to 220 and this, ns equal to 1, 2 and this, ns plus equal to 5. I redefined it. What do you expect? Like, just tell me the length of the final thing you'll get. We'll just see. Yeah, 1, 2, 3, 4, and 5. Okay, great. So we are adding arrays like strings. We are, doing a lot of things over here. It does not matter if the elements are of different kind. We can arrays just like indexed collection of data. The data can be of any kind. You are actually indexing it. I've told you how to iterate. Acha, how do you iterate? I guess that's covered. How do you remove the last element from an array? ns equal to 23 3 ns dot pop. That will actually remove the last element from here. I didn't print anything. So that will actually remove the last element here, over here. Right. ns dot pop is for removing the last element. Now, again, some miracle of Python. If you type 0 over here, what do you expect now? Like, if I print ns, what will I get? Yeah, great. If you type any index which you want to pop, any index, like if I just extend this, sorry, if I type 2, what will I get now? Oh, yeah. What will I get here now? Yeah, correct. I guess that should be for array. If I get more time, yeah. Very powerful stuff. You will see how these kind of manipulations help us to reduce the code. It is very much readable. It is very much like a English thing. Like whatever you think, you can actually type that and even check if that works in Python or not. It is really easy for that matter. If you practice it, you will be really strong in this, and it can help you reduce your code. It can help you write meaningful things, and even without any load on your mind. So I'll just stop over here. I'll let Yash continue. He will cover some basic ML things which we do in Python, installing libraries, telling some more things about libraries. If we get more time, I'll try to cover functions later on. Okay, so thank you very much.
Hello, am I audible?
Yes.
Yes.
Okay, cool. My screen is visible, right?
Yes.
Yeah, I'm Yash. I'm an instructor for the Intro to Machine Learning and Deep Learning course, and I'll be covering over some of the Python libraries. Basically, NumPy and Pandas for today. Uh, can you all mute, please? Tanmaiy.
Yeah, sure.
So basically, I'll be covering NumPy and Pandas for today, and how to install and get to this cool looking thing, and what this is. It's called Jupyter Notebook, but starting from scratch. So once you have installed Python, you'll be needing a lot of libraries. So one of the greatest things about Python is it has a lot of libraries that you can install and then use them directly. So it makes a lot of things easier for, everybody. So yeah. So once you have installed Python, just go to your terminal, and there should be a pip command. This is Python install package. So you don't need to, all this is not useful right now. So we type pip install Jupyter. I already have it installed, so that's why I did not take any time. So once you have Jupyter installed, this should be accessible to you. This is installed in your computer, and after that, so you just type Jupyter Notebook, and you get access to whatever I'm using right now. So it will open up in the directory that you are. Directory means folder, and so and once you have opened a folder, you can basically choose a notebook. So what I'll be using to teach you about the basics of all this is it's called a notebook. So yeah, you can open up a new notebook and start doing things. So I have this open a notebook right now. So notebook is like a combination of text and code, and why it's useful in ML and um, also in Python sometimes is because as you saw in Tanmaiy's code. All right, so as you saw in Tanmai's code, he was writing a bunch of code and then entering it, and then going back and then entering it. So the thing about notebooks is like each of these cells is like a file that Tanmay showed, and each of these can be executed individually, and these will all be in the same um, runtime. So basically, if I uh, tell Python that there's a list called something, and like instantiate a list here, I can also use the list here. So it's all in the same thing, but I can also like modularize it and change and edit my code anytime and edit parts of it. So it's also very useful in like plottings, and uh, so you can see these plots and how your data looks. Basically, data science, machine learning, all that is understanding your data and you know getting to know more and trying to do something with that data. So any questions up till now? Hello. All right. So yeah, basically all this is just text. I'll be sharing this notebook and the data that I use after this presentation. I'll share a drive link, and then you can go through this by yourself and like try on things on your own. So right now I have nothing installed in this. Like if I try to import a library called NumPy, it will give me an error. So what I'll do is I'll, exclamation mark is basically for commands that are not for Python. Pip install NumPy. Yeah. So now that NumPy is installed, I can run this cell. These are called cells. And now NumPy is imported as NP. So whenever I want to use NumPy, I'll call it as NP. Yeah. So a lot of these things are a bit complex for newcomers and beginners, but I'll try to tone it down as much as possible. Like, so basically, NP is the library that you're calling, and array is something in the library. The dot means go inside the previous thing and get it. So I'll also at the same time install pandas. We'll be using this later. So yeah. Now, as Tanmaiy already explained, this is I instantiated a list. So, okay, first I'll go over why use NumPy. NumPy is basically a way for you to handle your list and data better. So most of the data that we use in machine learning, deep learning, anything like that is converted essentially to numerical data. So even if you have text data, all those pixels are converted to pixels or group of pixels, depending on what you're using, into numbers. And even if you're using text, we have ways to convert that to numbers. We'll be covering that in our course, by the way. So yeah, so since we are using all numbers and list of numbers always, and that's why we use libraries that are good with numbers. So now that we have a list, we get this list into an array of NumPy array. So so the list type basically gets you the type of the variable. So a list, this thing is of type list, and array one, which I said here, is of type array. So yeah, I'll just this is another list that's being instantiated. So now I'll talk about like operations and everything. You should get a Jupyter in your terminal. Just type Jupyter notebook. Yeah, right. Yeah, so I'll be talking about difference of operations and symbols in lists and arrays. So you can consider arrays more like matrices, the matrices that you studied in your +2 and maybe in your M2. No, wait, you're studying M1. Anyways, so yeah, I'm guessing all of you know what a matrix is. So and list is a list. So when you add two lists together, it's like adding just concatenating combining these. So you get a combination of this. But if you're doing some operations on your list and you want some functions that can work, and like you're doing some things on your data, right? So you're trying to manipulate your data or use your data somewhere. So then if you use NumPy, it just adds the list together. So 1 is added to 10 and gets 11. So similarly, element-wise addition. Same for multiplication, division, and powers. So it gives you an element-wise multiplication, division, and powers. You can also use a function. So a lot of times, most of the times, you'll be dealing with functions and how to integrate them into. You'll have some complex formula in your programs, and then you'll have to convert that into code. So that's basically yeah. So you have like sign, and you just NumPy has these functions itself. So you go to NumPy and ask it for sign, and it gives you sign, and it applies sign on this array, and you get this array with signed numbers. Same with logs and exponentials. So so I gave NumPy a list, and then it converted into an array. But what if you don't want to like give it a data itself and just start with random amounts of data? So we go with NumPy. NumPy has functions that you can call to just instantiate empty list or list with arrays empty arrays are arrays with ones, or arrays that have numbers arranged in them. So yeah, okay. An important thing that Tanmaiy discussed was the second number that of the range that you call is not counted. So you see, I'm calling it till 16 and it's only till 15. So this is not included. Same with as he called ranges. So this is technically a range that we are giving to the arrange function. And the arrange function is giving me a list of numbers in those ranges with this specific difference. Line space is basically like it will make a line and then divide it into 11 pieces and then give you all those numbers. Again, I'll be sharing all this, so you don't need to fret over if you're missing out something. Just try to understand. Don't try to learn anything. Okay. So now, as I was talking about matrices, so mostly you would have been dealing with multidimensional matrices, like at least two dimensional matrices. So basically, two-dimensional matrix is a list of matrices. So you give it a list, and then you give it another list and another list. So you have three lists, and so this becomes a single row. Yeah, so we have three rows, and all those rows are arranged into the array, and hence it becomes a matrix. That's how basically matrices work, right? Yeah, when you look at the type, it's still a NumPy array. So sometimes if you have like huge amounts of numbers and lists and data, you need to know the size of those and dimensions and all those. So if you look at the dimensions, we have two-dimensional matrix. So we get two. Size is the number of elements. We get 9. Shape is 3x3, and data type is integers. All these are integers. Yeah, this is the same thing I talked about here, but with two-dimensional matrices. So we have zeros, but if you want zeros of multi-dimension, 2 dimensions, you can, yeah, multi-dimensions. So basically, same thing about ones and matrices of 5. So we got a matrix of ones, and then multiply it by 5 so to get a matrix of fives. Basic multiplication of matrices. You multiply a scalar with a matrix, you get this. I is identity matrix, and random int. I think I should talk about what the beginning of all this thing means. So another cool thing about Jupyter is you get a lot of information directly. So let's say I'm here. So let's say I want to instantiate, like start a matrix with random integers between 1 and 100, and I want 30 integers. But I know this. How will you know this? So you go to NumPy random, and you know that there's a random integer, but like how to know what value goes where? So you type shift and tab. It gives you a docstring. And docstring is basically a definition of the function and how to use it. So it says low. I gave low as 1, high is given as none, but I gave as 100. So I want numbers between 1 and 100, and size I want only 30 numbers. All right. Any questions up till now? If I'm going a bit fast, you can stop me and like ask me questions, and I'll explain some things if you didn't understand. No questions? All right. There's only one guy active, okay? That's okay. Okay.
How to open that Jupyter notebook, etc.
Yeah, so basically, okay, so you go to your terminal. I have this Anaconda terminals installed, so you can also use this. I usually prefer using this. So just go to Anaconda website, and you get started, and like it will give you some ads and all this. Download it for Windows. Once you download it, you will have a Anaconda prompt, which is what I'm using. So if you get Anaconda prompt, it should also give you Jupyter notebooks. So once you have Anaconda prompt, you just type Jupyter um, notebook, and it will open up a notebook in your browser, in your directory. So I was in my C drive, so it opened all the folders of my C drive. So if I have something, I can go and check. Any other questions? What seed part are you talking about? Can you switch on your mic and ask? All right. So seeds are basically okay. You read something. Okay. So for random numbers, sometimes you want results that are reproducible. So if you type in some seeds, I won't do it right now because then it would mess up the rest of the code that I've done. So, but like we'll explain this in our course. So like the first week we'll be covering all this about how to understand seeds and everything. Yeah, seeds are basically it gives you the same random number every time. So the result is reproducible every time. So let's say I set my seed to 42 or 34 or any single integer. If I use the same seed again, I'll get the same set of random numbers. All right, so we'll continue. If any of you have any questions or if I'm going too fast, just stop me and ask, okay? Yeah, I was explaining how doc strings work. So yeah, you go Shift Tab and you get this little information things about how this function works. And if you're still not sure and you want an example, you can just click on one of these things. Yeah. So it gives you a detailed explanation of what it means and what it returns. So every function returns something that I'm storing here. Okay, so when I'm calling this is a function that I'm calling. This random integer is a function that I'm calling, and it gives me a list of random integers. Now I need to store that random list of integers into some variable, which I can use later. So I store it into A. So the return function tells you what it's giving out, and then you have a bunch of examples about how to use it. So, right. So yeah, here the same thing. We have a random integer that calls random integers. Low is 1, high is 10. You can also explicitly call out like this instead of just giving out numbers like this. And size is 4, 3. So 4 rows and 3 columns. It gives me a random matrix of of numbers from range 1 to 10 of 4 rows and 3 columns. Also useful for testing out your stuff, models and things. Yeah, so now that we have A looks like this. A is just a random list of 30 integers from 1 to 100. Now I want it to be more arranged. I want it to become a matrix that is like 6 into 5, let's say, because 30 is can be said into 6 into 5. So I just called reshape. A is a NumPy array, and I reshape that array into 6 rows and 5 columns. So I get this. Now what's B? B has 3 numbers. So this is a 3-dimensional array. So it has this array and this array. So if you imagine it in 3D, like just put one on top of the other, something like that. But in this is how it looks like. So I reshaped it to two arrays of 3 into 5. 3 into 5 is 15 and 15 into 2 is 30. So 15 and 15. These numbers are arranged. And if you want to undo that, you just ravel. You get a flat list of numbers again. Tanmaiy talked about slicing of string, that how the string is sliced. You guys have no questions क्या? सब ऊपर से जा रहा है? Hello. All right. Yeah, it feels weird to just talk to nobody now, because in a class you have people to talk to. You can see their faces. Anyways, now I'm not gonna ask you to switch on your cameras. Same thing here. So I have this array. Arrange ka, does someone remember what arrange does? Yeah, I'm just glossing over these things. I'm not asking. If you don't understand any part, just let me know. I don't believe that even I would have remembered anything. Just glossing over things. So I'll be sharing this entire thing. I have these things written out, what's exactly happening, and you can run this on your own computer. And if you have doubts, you can ask in the Discord server or something. Yes, most of these things will be covering again in like revising at least in the demo classes. All right. So same thing about slicing of arrays. So how you slice into strings is how you slice arrays. So I'll tell you what arrange does. It just gives you all the numbers between these two. So it's like explain it. So now array is basically the array that we got. 7 is the seventh index, which is 7. So 0, 1, 2, 3, 4, 5, 6, 7. So index is basically how we arranged it. 3 to 8 means from 3 to 3 to 6, sorry. 3, 4, 5. So 3 to 6. And same things go all along. So this means from the start, because I have put no number here, up till 4. So yeah, these are written out in English. So if you want me to go over each of them, I can go. But I think they are explanatory with how Tanmaiy explained about how strings work, and like from -1 to -6 with a decrease of -2. And yeah, so we got arrange with increase of 2 instead of none. None will give me an increase of 1. So we got an increase of 2. So new array has like multiples of 2. And yeah, this thing I didn't talk about before. So if you have an array and you want multiple indices. So I want the second index, the fourth index, and let's say here the ninth index. So I can pass it a list of indices that I want. I want the second index, fourth index, and ninth index, and I pass this list to the array that I already have. So I'm giving it a list of indices, and it gives me the list of numbers that it had. Do you have any doubts in this part? Because I think it's a bit. All right.
The indexing starts from 0, right?
Yeah. Most of computer science and coding, always indexing will start from 0, unless it's explicitly mentioned somewhere that indexing starts from 1. So yeah, previously you saw that I did these two things on different lines. But I can do them together because that's a property. So I go to NumPy. I ask it to go into the directories of random things. I ask it to give me random integers that have these specific values, like from 10 to 100 with total 15 numbers. And I ask it to reshape the entire array that it gives me into 3 cross 5. So this is what I get. And the accessibility of indices of matrices are kind of intuitive. So matrix, I call it a matrix. So it's 1, 2. So you go to the first row and the second column, and so on. Yeah, these two are the same thing. It's just different ways of calling them. Yeah, so matrix 2 will give me the second row at index 2, not the second one. And this will give me the same thing as that, because I'm calling it in this format. So I'm calling it the entire row and the third index at 3. So it gives me that
In
77.
that random, it will just randomly select any 15 numbers.
Yeah, any 15 numbers between 10 and 100.
Okay, and just make it into a 3 by 5 matrix.
Yeah, the reshape is doing that. Get it? So previously I had talked about reshape here. So I did this in 2 different lines here. So I got a random list of 30 numbers, and then I called reshape on that. So I can just do this and call reshape here. And if I run this, A will become this thing, a reshaped matrix. Depends where you call things. So you can call your functions and like on anything that's giving you a list. So this gives me an array or a list, and then I call a reshape on that, hence getting a reshaped array.
What was that shape of A? There, shape of A, shape of B.
Yeah. So the
Yeah.
shape is this thing. Yeah, the shape is basically how I talked about here. Yeah, shape is for this matrix it would be a 3 cross 3, and for A has no other dimension, so it's just
So shape
30.
is the order of the matrix.
Yeah, kind of. Yeah, basically the shape is order, right? Anything else? So matrix 1 2 gives you a first row second index, same thing as a matrix 1 and then bracket 2. As for the reshape with 3 numbers, it's reshaping it into 3 dimensions. So like it's giving you a cuboid. If you like try to imagine it in 3-dimensional terms, like usually 3 dimensions you can imagine, but sometimes if you go further, like difficult to understand what's happening. So 2D we get 6 cross 5, and then we say ki I want another 2D that's on top of this. So it becomes 3D, right? So
So it's a
something like that.
matrix in 3 dimensions.
Yeah. So it's a 2 cross 3 cross 5 matrix. Did you get it? Yeah, that's why we say don't try to imagine it and just like understand that these are list of lists instead of trying to imagine it in 3D. Yeah, the 3-dimensional part was just me trying to explain you how the matrix is. So it's technically a list of lists, right? So this list, this bracket and this bracket consist of two lists, this list and this list. So this list consists of three lists, this list, and this list. So that's how we define the shapes. Yeah, so A11, so yeah, as I said, in computer science, you basically your indexing starts with 0. So A0 matrix 00 would print A11. Yeah, if I change it to 00, it should give me 24 instead of 73. Oh, wait, the random numbers change. So the random numbers change to this matrix, and now we have the first A11, as you said. But the indices start with 0. When you start with coding, and even in any language, this is a thing that's hard to get your head around, since you have always been starting your indices with 1.
But why do we need matrices in coding?
Yeah, as I said, so let's say you're working with images in machine learning or deep learning, anything like that. If you're working with images, the machine that can basically understand numbers. It won't understand what the pixel means. Like, it needs to have some numbers to it. So we give the numbers as the color values or something like that. The pixel values, the pixels have RGB values, kind of like that. As for text, if you're trying to give it text, you must have seen like cool demos of people talking about how transform, like how machine can, how chatbots work and all those um, AIs. Same for something like OpenAI's chess and all those. Everything is translated into numbers and then given to the machine to process. And then it's translated back to understandable output for us. Yeah, kind of like that. We'll not be going over how exactly it works because like it's a bit complex, and uh, we'll be covering that in the further weeks of our course if you decide to join it. Yeah, where was I? Yeah, indexing. Same thing here. So this thing means the row, and this means things. Uh, this means the columns. So row 1 to 3 and columns 3 to 5. That gives me this thing. Same thing here. But this time I'm calling so row 0 to 2. So 0 and row 0 and row 1. And I'm calling columns 1 and 3, not 1, 2, 3. So this means a range, and this means some indexes. So as we did over here, we passed a list of indices to get all those numbers. So second one, and the at second index, at fourth index, and at the ninth index. Same thing we are doing here. We are giving it a list of numbers and telling it key I want the first and the third column in this row range. We get this. Yeah, the first at index 1, the first column and the third column. Yeah, 1 and 3. We're getting that. Yeah, so conditions. Okay. Yeah, conditions. So sometimes we have this list of matrices, and you want to. I'll get to data analysis in some time. We'll get to how you can use tables and all those and try to analyze the data with pandas. That's the library we imported previously. NumPy is basically numbers, and table pandas uses all these to make it presentable and make you understand much faster. So we have a matrix. We have this matrix, and I want all the elements that are greater than 50 in it. So in the index, we always pass the things that we want in the index. So we go to index and tell it ki, in matrix, whatever is greater than 50. So it gives me a list of, what do you call this? Booleans? Yeah, Booleans. True, false values. So anything that's greater than 50 will give me a true. So 90 here gives true. And then it passes that to this matrix that we have here. And that's, if it's true, it will give me that value. If it's not, it will not. As simple as that. So now this is a matrix multiplication thing. So you might true is considered 0 and false is true is considered 1 and false is considered 0. So this is element-wise multiplication because yeah, this is element-wise multiplication. If we want array cross array multiplication, we do this thing. We have additions, as I explained about additions of indices earlier. We have multiplication of these arrays. Simple things that you learn in maths, like linear combination, addition of scalars, but exponents and powers, cubes. Cubes is basically an exponent, yeah. So that's the basics, extreme basics of pandas. This is still a lot to process. I'll be giving you the notebook I've cited. You can go on to their documents. So the documents are a bit hard to process right now. We'll covering how to understand documents and how to understand how do I come to this random integer? How did I know I need to use random integer or reshape? So we'll be covering this in our first week of the course. Up till now, up till NumPy, only numbers. We have used nothing, no data. We have only given it numbers and tried to use this. We'll now try to understand how we use those numbers in proper data analysis. Up till now, if you have any questions, let me know. I'll just keep putting it in the chat. I keep checking the chat. So I'll just try to answer your questions.
NumPy is a Python library, right?
Right.
So why can't we directly use it on Python? Why we need to download a separate application and data?
This thing, you can use it directly in Python. So we go to Python. I mean, it's usable. I didn't need to show you. Yeah, we have NumPy. We can use NumPy.array and add 1, 2. What happened? Oh, I did not import that as NumPy. Yeah, we can directly use it. So this is basically because it makes things easier. So this is I'll go over it again. It's called a notebook, a Jupyter notebook, and you also get. So first things first, this is very easy to use because your code is modularized. So if I need to change something in my code here, I can do that, and then I go run something over here. Because if you have very long codes, it becomes difficult to change parts of it and then run the entire thing again and again. So that's one advantage. The other thing is you get to see what's happening. You get to experiment with your data. We'll be covering that, how to look at your data and what's happening in your data. So Pandas does this. Yeah, but if basically,
got it.
all right. So yeah, if you have any questions, just keep putting it in the chat. I'll check. Pandas now. Pandas is more about tables and yeah, mostly about tables, right? So a lot of numbers and matrices are basically just tables. And sometimes we have some labels to them. So we have column names, we have indices, here index. We can name the index however we want. So yeah, uh, so we get to pandas. This was panda series. So I'll start with what's a series and then we'll go over what's a table. So we got a list of alphabets, ABC. This can be anything. Again, a list of numbers. We did not cover dictionary, so don't fret about this. We'll cover this in our course if you want, but it's not so important. It's basically a form of form of data, like lists or so. Uh, we have array that we got from NumPy. Um, so yeah, when we give this to pandas, it basically converts it into a table kind of format where you have an index to each of the numbers that you gave it. This becomes much easier for accessibility and understanding what's happening, or like editing your data itself. If you have a long list of, let's say, um, CSV is basically called a comma separated files, but like it can also open in Excel. So basically large tables. We need to edit those. You use something like NumPy. We got series. The data for this series is my data, which is these numbers. So here, this is where it becomes a bit useful. Yeah, this series we have data that we give my data, and we call these index as labels. We got ABCs here. Same thing with all the other kinds of data. Yeah, getting to data frame, like why we are talking about all the NumPy numbers and series. So again, we get this NumPy 5x4 matrix of random numbers, and we get the row labels that we want, and we get the column headings. Anything that we want, we'll use a real world kind of data in some time, and we call a data frame object. The data frame is basically this thing. It's called a data frame. We'll be using it as DF. So we use PD because we called pandas as we set pandas as PD. We imported pandas as PD data frame. The data is the matrix data that we created here, a random number list. Index is what this is. Columns is like, yeah, this is explanatory. This is not very useful. This is basically for these dashes. So again, I was talking about shift tab, right? So I go to data frame and I press shift tab. It did not run yet. Okay, I did not run this. So we import pandas, we run this. We have this and called shift tab. So you see the documentation of data frame object. You click on this thing, tells you what exactly these means and what you can do with it. And it should give you some examples about how to go around it, what else you can do with it. Yeah, so documentation, all of them have like some documentation to tell you what exactly this is, if you get stuck somewhere or something like that. Yeah. So again, we have a dictionary. Don't worry about it. It's basically a list, and so basically dictionary is list and labels made together. What exactly this is, we'll be explaining this later. So don't fret about dictionaries. We do the same thing that we did here about creating a data frame. So we give data as a dictionary. So it already knows these column headings and then in numbers because we combined those two as a dictionary. And we have index as X and Y. So using a real world data, I have this data called wine data, which talks about different kinds of wine and their, levels of things that they have in them. It's shift tab. Okay, shift tab is for getting the doc string. Shift enter is for running the Shift enter or control enter. So control enter just keeps you in the same cell, and shift enter gets you to the second cell, the cell next to it. So yeah, I got this data. So yeah, I have it in the, we have a vine data and a height data. So CSV is basically comma separated values. Looks something like, maybe if this will open. Yeah, these are separated by commas, but Google can read this, so it gives you this. And this is basically an Excel about heights. So we import this as us. So Pandas can read a lot of data types. So it you can follow this link for more data types, but basically CSVs are mostly used. So pandas ed dot read CSV and the path of where your CSV is located, and just store it here. So we have a data frame object, a table object that we are storing it in our Python program. Now we can do whatever we want with this thing. So head is basically, it tells you the first 5 rows, gives you first 5 rows with columns. So, and same thing with Excel, you can import a Excel sheet. Up till now, do you have any specific doubts? Yeah, pandas and NumPy are different things. They are different libraries completely. Yeah, Jupyter Notebook, as I explained. So yeah, now that we have these two, what happened to you? Okay, guess pandas require something. Okay, this is a version issue. We'll skip over this now, for now. I'll try and fix this before, after giving it back to you. So yeah, as I explained, what head gives you the first 5 rows. If you put in a number, it will just give you the first, the first 3 rows. And tail is like explanatory, like last rows. The number gives you last 7. Sample gives you some random rows. And now, so this is the power of pandas. You just call some functions, info, describe, or mean, standard deviation, min, or variations, anything like these, and you get instant outputs about what your data is and how it ranges. Give me a second. So info, you get basic info about like counts and data types and your columns. So these are the columns, right? Column names. We won't worry about data frame 4 for now. These are already run outputs. I'll try to fix that thing, and like maybe it's a issue with only my thing because I tried to make it from scratch because I already have. Okay, I'll not explain what happened. Transpose is how transpose works in matrices. So yeah, describe, what exactly does describe do? Shift tab. Descriptive statistics include summarize. of the central tendencies distribution, mm, NaN values. So yeah, like most people, like even I don't remember what exactly everything does. So you just press Shift Tab or some and just Google it and try to read what it exactly does. So describe gives you all these things. So first, 25%, 50%, maximum values, standard deviation, min values, mean count of these, um, and transpose gives you the transpose of that. So this is basically your basic descriptions about whatever this thing is. So we have 178 rows for each of these columns. We have the mean of them, standard deviation, min, 25, 50, 75, and maximum. Yeah, don't worry about these specific numbers and what they mean, but understand that describe function can give you some descriptions about numerical descriptions, at least about what your data frame is about, or like your data is about. So these give the specific values instead of just describe standard deviation. All these give the specific values that you have. You can call these functions. So min or max. Yeah, if you have any doubts, please switch on the mic and ask, because I'm almost done with this and time's almost up too. So I'll be happy to answer any doubts, because most of this is just me continuing about how you can use this, and all these libraries are endless. So yeah, if you I guess most of the doubts were about how installation of these works and how pip works. So pip is a Python installation package. So you type exclamation because I don't want it to run in Python. So anything I type in these cells will run in a Python environment, and I want this to run in my terminal but I don't want to access my terminal right now. So pip. So yeah, there are a bunch of these libraries are just the basics of how numbers and all those works. There are a lot of libraries that we use, and you can also like use. Sometimes we don't use all the libraries. So we have this torch. Okay, it's called PyTorch. We import it as torch. PyTorch is a library which you import as torch. I think. Yeah, so we have PyTorch. We'll be teaching you some about other libraries. You can I think there's a library from our college as well. It's called GenRL. It's from the Society of AI and Deep Learning, the CEDL ID. Yeah, but you can. Oh, Somesh is here. Yeah, we not just commands like functions, classes. We'll be going over object-oriented programming and how classes and functions work properly. But yeah, technically, yes, they're just a list of a bunch of Python, you know, commands, not commands, files. Yeah, well written is the keyword maybe. Yeah, so import is basically helping you get the file into your Python program, right? So it doesn't have to be library that you installed. If I have something in my data set, like in my folders, I can just import that. But technically, that's also a library, right? I mean, it is a library, not technically. Any other questions about whatever I explained today or how How do you open NumPy and if you just open your Jupyter Notebook and import NumPy as NP, we prefer NP, but like you can just import as NumPy. It should work. Yeah. Yeah, the docs are a very important about thing about like learning how. As I was explaining repeatedly, you get doc strings with most of the functions, and you can just go to the websites and NumPy. Installation get started. Mostly about Conda, or you can just go to their docs itself. So yeah, the manuals and the documentations. I was also planning to cover like um, matplotlib and C1 to visualize your data. I guess we'll be doing this in our demo classes then.
I guess that should be it for today.
Yeah,
So guys, just one moment. So guys, Yash is actually the instructor for MLDL course, and I am mentor for competitive programming course. Do join our courses, and you'll get this link. You'll get this class on the YouTube as well. You can continue, Yash.
yeah. I was saying that I was just gonna yeah. This is basically the documentation, so examples of whatever I just explained. Some these probably have a lot more details. Yeah, I was saying if you want, I'll just share this. Did I already copy this? There's nothing called as best because like you can't do ML just from pandas. You need some networks and your models to work, right? We'll be explaining this like this is a broad topic. We'll be explaining this in our first weeks. Can someone check if they can access this? It should be accessible from your Bits account. I guess they can also they'll also put it in description of YouTube. Cool, cool. So is Tanmay still here? Where is he? Tanmay left. I guess that's it. If you have any questions or anything to say, guess I'll see you at the demo classes then.